I'm looking for, is there a go live? Oh, it's already recording. We might already be live. Is that right? Let's see.
Like it.
Yeah, it's a recording. It's not go live. It's just recording, so people can review it later.
Oh, but we're not live yet.
No, we are not live yet. Yeah, this is live. This is live. People can join in now. Yeah, joining here.
Oh, it is live. Okay.
Okay. Yeah.
All right. Hi everyone. We'll get started in just a minute. Tim, do you have? I think you sent the slides over to share to somebody, right? Do you want us to put them on? This will also give everybody a minute to join, which I think is fine. Did we lose you, Tim? Oh, here we go. You came back. Tim, can you hear me?
I can hear you.
Yeah, I was wondering if. Oh, Tim, you can hear me?
Yeah, I can hear you.
All right, I think we are live now. So,
but I was having some connection issue.
Yeah, your voice is still breaking up. I'm not sure if it's because you're outside or.
Yeah, I'm getting an echo of a sort when Tim speaks.
All right, let's wait for him. If not, we will have Tim come back later and he can talk about the community.
Weird. It's really weird.
Tim, maybe get off the video and it seems better now. I'm not sure. Maybe you get off the video and just do audio. And I see people are joining. That's awesome. Hello, everyone. We'll get started in just a minute. All right, I'm going to share real quick. Ooh, that's not probably what I wanted to share. Patrick, what do you see? Do you see my terminal or do you see?
Accelerate your career in data science, machine learning, and AI.
Perfect. That's Tim's slide. So Tim, if you're here, if you came back, this is your chance. If you're just joining us, welcome. We'll just get started. We're waiting for Tim to come and tell us about this amazing community they have. And also there's some free resources that you'll all have access to, which is pretty cool. All right, he's back. Let me add him back as a host.
Okay, can you hear me?
I can hear you. Can you see the slide, Tim?
I can. So yeah,
go for it.
Hi everyone. My name is Tim Bonneman. I work on the IBM data science community here out of the beautiful Bay Area, and just wanted to share this offer. If you join the community, you get 1 month worth of complimentary access to select IBM courses. They're pretty good. We get good feedback, so definitely check it out. And on the community, we have about 14,000 data scientists, ML engineers, and others, sharing their work, their projects, their insights. So definitely worth a look. And hope to see you there and enjoy the meetup.
Wonderful. Thank you, Tim. Patrick, I'm going to stop sharing and I'll let you bring the slides up if you don't mind.
Sounds good. Give me just 1 second here. I need to make sure my VPN is still connected. Going to start sharing my screen. And then, all right, presentation mode, we're good to go.
We're good to go, perfect. So again, let me, give me 1 second. I'll bring up, perfect. All right, So welcome again, everybody. Sorry for a little bit of a late start here. We had some connection issues, but hopefully the course, the free course in the data science community that Tim showed you, hopefully makes up for those glitches. My name is Upkar. I'm a developer advocate at IBM, and I'm joined today by my colleague, Patrick. Hey, Patrick.
Hello.
And we are here today to talk to you about Elyra, to introduce you to Elyra. So I see, I see some attendees who are watching us live. If you can let us know in the chat, have you heard of Elyra before? Do you know what the open source solution that we'll talk about today? Have you heard of that before? First time, okay. Felix, first time for you, okay. Anybody else? I'm just curious to see. Tanya says maybe yes, okay. Anybody else? And also, I have another question, actually. If you could let us know once, I think first time, nope, okay. All right, well, a lot of newcomers. This is perfect, Patrick. My second question is, I know this is, this is a data centric, data science centric meetup, but I'm just wondering how many folks in the audience are data scientists versus interested in data, but do something else for a full-time job. If you can let us know in the chat, that'll also help us out during the talk and during the demo. We can cater a little bit to the audience. Data scientist, Ashish, thank you. Very cool. So a lot of deep data science experience. That's really good to see. This tool will be. I think you'll find it useful. Again, I've introduced myself, Patrick. If you there's some more introduction on my part. I forgot about this. So I am part of the IBM developer team. Primarily work on this hackathon called Call for Code. It's our annual hackathon. We just announced winners for last year. So if you're interested in building solutions to help communities in need, it's sort of a code for good kind of hackathon. The interesting part is, if you win, you get $200,000 in cash prize, but also you get help from IBM, from the Linux Foundation, and other open source companies to help you actually stand up your solutions on the ground, right? So you get a lot of help and collaboration that way as well. So if you're interested, Google Call for Code, IBM, it'll take you to that site. We just launched another one. It's called Embrace, and I'll let you read more about that on the website itself, because I know we're here for another topic today. Apart from that, I am also author a couple of courses on Coursera. So I know Tim gave you a list on his site, but if you're interested in containers, Kubernetes, OpenShift, that side of things, which I think is becoming more and more relevant for data science, and Patrick will go into the details a little bit more later. So I see Daniel is very interested in Call for Code. Amazing. Okay, cool. I'll also paste the link in the chat for you. All right, with that, Patrick, I'll hand it over to you for a brief introduction.
All right, thank you, Upka. So first of all, thank you everybody for joining us today, and of course for inviting us. My name is Patrick Titzler. I'm a developer advocate with the Center for Open Source Data and AI Technologies. Our team is based primarily in the San Francisco Bay Area, but we have about 40 plus developers and data scientists that are working alongside us on various open source projects. And what you can see here on the right-hand side is just a small selection of some of those projects that we are actively contributing to. And I should probably say, so those 40 developers, most of them are contributing almost full-time to projects. But as you can imagine, being part of IBM and open source being so important for all of us, we have several thousand developers globally who are actively contributing to open source software, not just in the general area of AI, but across the entire open source software stack that you might be using on a day-to-day basis. In the session today that Upka and I are going to lead, we are going to focus on one very specific project called Elyra, which is part of the Python data science stack. And this is what you can see on the top of this little chart, surrounded by a little box, just to highlight it. What we are going to do is give you a brief motivation why we created the Elyra project. We're going to show you a demo of the highlights of Elyra, and then we're just going to open it up for some Q&A at the end. I'm going to give you a live demo, and while I go through the demo, I will not be watching this, the chat. So what we're going to do is Upka at any time will be able to just interject. So if you have a question that you would like to get answered, either he can answer that question in the chat, or if it sounds like a question that would warrant a longer personal answer, then he can just bring it up as I move along, and then we'll discuss the answer here on the air. Last thing I wanted to say about these projects that you are seeing here, these open source projects, some of them, like the AI Fairness, the AI Explainability project, or the ART project, were created by IBM Research. So those are some of the open source projects that we are contributing to, but you can also see a bunch of very familiar open source projects like TensorFlow, like Apache Spark, like Pandas, or scikit-learn. So we, as a team of developers and data scientists, are actively contributing to a lot of those open source projects that are relevant in the general area of artificial intelligence. So with that, Upka is going to go through a brief motivation.
Right, thank you, Patrick. So, when we asked a question earlier, I see there are a couple of very experienced and professional data scientists in the group here. So, I mean, this picture should not come as a surprise to anybody here. Although I did ask a question, I asked if you use Jupyter Notebooks or Jupyter Labs in your daily work. So there's one answer saying, no, I'm here to learn. That's wonderful. You're most welcome. And we'll do our best to show you the solution today, and hopefully it'll be useful to you. For the data scientists in the room, do you use Jupyter Notebooks or do you use Jupyter Lab? Have you worked with Jupyter Lab before? Generally not thus far, but starting to do so for certain classes. Okay, very cool. That's good to hear. Yes, of course, Prosper. So if the answer is yes, of course, I'm curious also to know, what are some of your pain points in Jupyter Notebooks? They're wonderful for a lot of use cases, right? So for me personally, they're wonderful to experiment. They're wonderful to break things and quickly fix them and fail and then succeed. And it's every cell, it's easier for me to work around the cells working by myself than a big .py file or Python file where I have to jump back and forth. So and the second thing, it's a really amazing education tool, right? So when I'm doing webinars or I'm working at mentoring at hackathons, I find them very, very useful to explain something to somebody, because each cell kind of, it depicts a step in my algorithm or in my modeling, and I'm able to say, okay, here's we acquired the data using, normally in our case, it might come from a cloud object store, it might come from a CSV file sitting on GitHub if I'm using Pandas to do some data massaging or whatever. So, acquiring data, analyzing data, processing data, I have different cells for those. It's easy for me to show. And then I have one cell just for training of that data using something like scikit-learn perhaps, and then I'll deploy the data. Deploy the model to something like Watson machine learning available on IBM Cloud. So if you're new to data science, these are sort of the typical data science lifecycle, right? So they say 90% or 80% of data scientists' work is actually working on data and cleaning the data. Because trust me, like in real world, Like Kaggle is not real world. Well, some competitions are real world, but for most part in Kaggle, that they clean up the data before you get it, right? I worked at school districts across the United States and we used to work with student data, their historical grade data and other kinds of data, right? Also some private data like health data and things like that. And it was so hard to get all of the schools to talk the same language when it came to data and tables and what kind of databases to use. They were all over the place. So I agree with that sentiment completely. So acquiring data, then once you have the data, a lot of times the data is you're brand new to the data. So you take some time to get used to the data. You need a certain level of intimacy before you get into close to any sort of modeling, right? Because the kind of data would influence what kind of models you pick in sometimes. So once you've analyzed the data, you may start to process the data, which could mean cleaning the data up, removing certain kinds of noise from the data, looking at outliers and how the outliers will affect your modeling. And then you start working with models, and you never just pick one model and go for it, right? The general tendency is to have a couple of models compete against each other, and you pick the best model based on certain evaluation criteria, which again depends on the problem, depends on the kind of data. But let's say you've done all of that, you've optimized your parameters, you have done some feature engineering to find new features that work better with the data that you have. And then at that point, you're ready with your model. You have a really good ROC curve, or you may have a really good error rate or whatever cost function you're trying to minimize. And at that point, you have your model, you want to deploy it. You, again, like I said, you want to deploy it at scale. So you go to something like Watson Machine Learning on IBM Cloud, and you can deploy that model. And then that's not the end of the story. Then you start monitoring that model. You start monitoring that model for performance. And also you start looking or monitoring that model for bias, right? For bias detection, which is a whole different webinar on bias and explainability that we have done in the past as well. That being said, I'm looking at some of the answers here, and Andre is saying revision control is the biggest pain. I completely get that. Have you tried diffing two IPYNB files? It's a pain. Like I used to work on Apple mobile apps, and they use Xcode, and I forget what it generated. I think it generated XML. It was really hard to compare again. Let's see. Daniel, great notebooks are great for prototyping algorithms and documenting data analysis flow, but difficult to develop or debug in a reasonably large body of code using notebooks. Perfect. That you're leading me on to my next slide. That's awesome, right? So those are exactly the pain points I experienced as well. When I was using notebooks, there was no way to use MVC for visualization-based apps. MVC, is that like model view controller for creating web applications and then do some sort of visualization? That's an interesting thought, Daniel. Yes, yeah, that's an interesting thought. Okay, so, as the picture says, a picture says 1,000 words, although I've probably said more than 1,000 words. You can see the top one is our typical notebook where you have a bunch of cells. It's monolith, it's doing many things in the same notebook. And at the bottom is what software engineering good practices tell you to do. They tell you to break your code into modular pieces that talk to each other. There was a really good line I read in a book. It said, monoliths are strongly coupled, and then microservices or modular code is loosely coupled but strongly aligned, right? So they're all working towards that same goal of making a really good software, but they are not. They might be dependent on each other, but they're not. They're still modular in that sense. So that brings me, Patrick, if you can move to the next slide, and we'll show what people have already said here, right? So this is unless Patrick shared the slides beforehand, you kind of read our minds, right? These are common problems. So how do I reuse code in Jupyter notebooks if I have a team working on a single notebook? Now, I know in Watson Studio, which is our machine learning product, there's ways to collaborate, but still it's hard. It's hard to share notebooks and share cells inside notebooks. How do you do that? Source control or version control, like Daniel was saying, it's a pain right now. The other thing is running remotely, right? So I'm on my Mac and I'm working on this notebook, and I'm working with a bigger data set, and it's taking up a lot of resources. How do I take that work and offload it to another server or something on the cloud, right? So with Jupyter Notebook, if the notebook is running on the cloud, that's a different story, right? If you're using Colab or if you're using IBM Watson, that's a different story. But how do I run individual pieces of code or certain pieces of code remotely? And the other one is like, how do I run batch jobs, right? So that's where maybe once a day or something, your model goes off, picks up data, and then runs the prediction, gives you back a result in a CSV file. How do I do that? And how do I schedule batch jobs, right? That's another problem with Jupyter Notebooks. And then the last thing is ML workflow. So again, as Daniel was hinting to, it's good to experiment. It's good for prototyping algorithms and models. But then now you have this cell after cell after cell of code. What does that workflow look like, right? So let's say I want to now get a new data set in, but I don't want to change, or I want to change like some things in the middle of the notebook without touching the top part. How do I do that? Another thing with notebooks, which I always get into trouble with, is the order of the cells doesn't matter, right? So if you run something at the bottom of the notebook, it's whatever variables are stored in memory, and then you go to the top and everything still works fine. And a lot of times I tend to run them in a random order, and either it's not going to work, or I tend to overwrite my variables from previous cells. So in either case, I get into trouble. Apart from that, like the whole workflow, so we talked about getting the data, processing the data, doing feature engineering. There is a way to do a data pipeline. Andre, so I realized that, are you referring to, like, for example, scikit-learn has this whole concept of data pipeline where you're sort of plumbing different parts together to create your ML pipeline? So yes, I get that, but you're still doing everything inside a single notebook, right? So with that being said, yeah, exactly, Andre. Yeah. So I realized there's that way to do it, but you'll see how that changes with Elyra, and it's a different way of thinking about the whole pipeline. So Patrick, with that, I'll pass it back to you.
Right. Thank you, Upka. So what we're going to do in the remaining like half hour to 35 minutes that we have left here is just give you an idea how some of the features that Elyra provides can help you solve some of those issues, right? That you're dealing with on a daily basis. And then sometimes the thing is, if you have to do the same thing over and over again, little problems that you run into or little usability issues can get very quickly very annoying, right? And so what we have done is we've done some analysis. We looked at, so what are some of the typical tasks that you as a data scientist would perform on a day-to-day basis? And then we've tried to come up with some solutions, right? How can we extend JupyterLab in such a way so that we do have the ability to reuse code, right? And for that, we are introducing the code snippet editor, which allows you to do exactly what the name implies, right? You define a piece of code that you register someplace, and then you can insert this code. You can insert that code, for example, into a notebook. If that code happens to be a markdown, you can insert that into a code into another notebook cell that is tagged as being a markdown cell. You could insert code into a Java app if this is what you do more frequently. With respect to source control, you'll be extremely happy to hear that with Elyra and JupyterLab, you now have a Git integration. So if, for example, if Upka and if we are working on the same project, we can now share our notebooks and our other artifacts within JupyterLab by exploiting the Git integration extension that we're going to show you. If you have, for example, a training job that you have built, which could be, for example, a Python script, we have the ability to run this on a remote machine, right? I mean, probably the way you do this today is if you have access to another server, for example, that has more powerful hardware resources that you can utilize. You SSH into that machine, and then you run the script there, right? But as you can imagine, as you know, this is not very efficient, right? And with Elyra, we give you the ability to run the script from within your JupyterLab environment on that machine, and then access the results that this script is producing within your JupyterLab environment. With respect to having the ability to run a notebook as a batch, right? Upka was mentioning this earlier. If, let's say, you have a notebook that comprises of many cells, of course, yes, you do have the ability to run all the cells, right? But still, you have to open the notebook, and then you have to click that button to run through all the cells. We do have a feature here that in Elyra that allows you to take a notebook and then submit it for execution in a remote environment. So for example, if you have access to a particular server that has the resources that you need to run this notebook in an acceptable amount of time, you can just submit it, and then it will run on that machine, and you will have access to those results again within your JupyterLab environment. And last but not least, implementation of ML workflows. We have implemented a pipeline editor, which gives you the ability to chain notebooks or Python scripts together so that you can automate certain tasks that you're performing on a daily basis. So that, for example, if you need to load data and cleanse it, you don't have to run each one of the notebooks individually, but you can create a pipeline that combines those two notebooks. And then when you run the pipeline, you get the output from both of those notebooks after that pipeline has executed. So for those of you on the call who are not familiar with JupyterLab, when I go through the demo, I'm going to give you just a very quick overview. But before I do that, I wanted to say a few words about how you would go about implementing a machine learning workflow using pipelines. So let's assume you did what was mentioning earlier on, right, where he said it is a good practice to create modular notebooks, right? So notebooks that tend to do just a few things, but not everything, so that you can reuse them in other projects, right? And one example that I like to give, and you can also see this here in this little workflow diagram that I have. Let's say you have a set of notebooks that process some data, that analyze the data, might perform other operations over that data. Now, that data might reside in a database, it might reside on cloud storage, it might be in a GitHub repository. Ideally, your notebooks shouldn't need to know, right, where that data is living. And if you have created, for example, a Python script or another notebook that just takes care of the data loading, right, then you can abstract the fact where that data resides from all the other notebooks, right? And you suddenly start to have this set of notebooks and scripts that you can reuse over and over, right, in different projects. A pipeline is nothing else but a combination of Python scripts and Jupyter notebooks, as you can see here. The scope of such a pipeline, it's completely up to you, right? So whether you're trying to build a pipeline that does every single task of typical data science workflow, you can do that. If you just want to combine a set of subtasks, you can do this as well, right? So for example, if you just want to load and pre-process data in the pipeline, you just combine those two in a pipeline that you create, and you run this pipeline and you get the results, right? If you want to do more, you just keep adding more nodes to your pipeline. So before I actually show you how you would go about creating a pipeline, I did want to spend a couple of minutes just introducing you to Kubeflow in case you have never heard about it. So what I've pasted here on top is the formal definition, right? So if you look at the documentation for Kubeflow, it says, okay, it's a scalable, portable, distributed machine learning platform that runs on Kubernetes. But what does that really mean? So think about a very simple scenario where you are a single, let's say, data scientist, and you're working on a project on your own, right? So you start looking at the data, you start analyzing it, probably looking at fairly small amounts of data. So you're going to use your JupyterLab environment, right? And mostly you're going to use your notebooks to perform those steps. You might then go through the exercise of building a model, of training a model, then figuring out, okay, which one of the models that I have created is performing the best. And then you decide, okay, I have a model that meets my prerequisites or it meets my stated goals, and I can now start to serve this model, right? By, for example, implementing a little web app that surfaces some functionality that is utilizing the model that you have created. Now, this is all good and fine if you are a single data scientist or a small group. But when you think about the problems that arise from an operational point of view, if you're trying to do this at a scale, right? What if there are hundreds of users who are working with notebooks? What if your models require gigabytes or terabytes of data, right? You're not going to run any of this on your local machine anymore, right? You would want to take advantage of hardware resources that are available to you, either in a data center that you have access to, so it could be a set of servers. So for example, if you are a student at a university, if you are a research assistant, you might have a bunch of servers available in one of your labs that you can use, right? If you are in a startup company, right, you might be leveraging cloud resources that Google, Amazon, IBM, or Microsoft provides. Or if you're an enterprise, you might have access to a combination of those services, right? So you might have a bunch of servers running in your local data center, and you also might have some resources that cloud providers are making available to you, right? And with Kubeflow, you can scale your operations, right? So because Kubeflow is implemented on top of Kubernetes, and Kubernetes is pretty much supported everywhere, right? So whether you have a server that you're running in your data center, all of the major cloud providers are supporting it. So you have now achieved portability so that you can perform any of the steps in your workflow in any of those environments without really having to change anything, right? And as you get involved, or if you are already involved in a lot of large-scale projects, you very quickly see that operations is becoming a major effort for everybody involved, and just making sure that everybody has access to the resources that they need. For example, when you run a training job, that you get the resources you need so that this training job completes in a timely manner. And when you maintain the models, that you make sure that at all times you are not just wiping out an existing model, but you have the ability to switch between different versions as needed, so that you can find out, okay, is the new model version that I have now deployed, is it performing better, or is it performing worse than a version that I might have previously deployed in my environment? Now, Kubeflow pipelines is one of the components in Kubeflow, and its main purpose is it serves as a platform for building deployable, portable, and scalable machine learning workflows. And what I'm showing you here in this graph is just an abstract workflow that you have to complete if you want to create and run a pipeline in a Kubeflow pipelines environment. First step is you use the Python DSL, and DSL stands for domain-specific language, to define the pipeline artifacts. So what are the components that make up the pipeline that you want to run? Once you have defined that, you compile this into a workflow specification, which is something that Kubeflow pipelines understands and knows how to process. Then you upload that specification to Kubeflow's pipeline, and then you can run that pipeline in the environment, where it will then be processed using all of the resources that are available in that Kubernetes deployment on which Kubeflow pipelines is running. So how is this different if you're building pipelines with Elyra? So in the previous slide, I was showing you, okay, there are several steps that you need to go through and some coding in order to assemble those pipelines. With Elyra, we are providing you with a visual pipeline editor that allows you to assemble those pipelines just using a graphical user interface. And we under the covers, or Elyra under the covers, takes care of generating all of the artifacts that are required to run those notebooks or Python scripts in the target environment, right? So we make it a lot easier for you to just take whatever you already have and then run it in an environment like kubeflow's pipelines. One important thing that I do want to mention, because I do realize in a development environment, right? So let's say you're just starting off where you are trying to build your model. It does make perfect sense to run a pipeline locally in JupyterLab. And within Elyra, we give you that opportunity. So there are certain use case scenarios where you can run those pipelines in that environment. But then there are other scenarios where you would really want to run those pipelines in the cloud or on a different machine that has more resources available to you. So this is where I'm going to switch to the demo. Before I actually do this, I'm just going to open up for any questions, Upka, that people might have asked that are worth going through.
Yeah, for sure. There's a question on Kubeflow.
Okay.
So the question was, has the Kubeflow team developed the event triggers to make the pipeline flowing? One container needs to signal to notify the other stages to start running. And Andre is saying a few months ago, Kubeflow didn't have this functionality. Is that something that's implemented on the Kubeflow side?
So I don't know if this is event specific, but in general, yes. If you have defined a flow where you say that one part of the flow is dependent on the other, it will only kick off the let's say the second component after the first one has successfully completed. So in that respect, it already does what you're looking for. But you might be specifically interested in a slightly different feature, I guess, where you want to dynamically somehow trigger execution of something else that isn't necessarily part of the flow. If that is the case, maybe this is a discussion that we can have offline.
Perfect. And then I know you went through the pipeline stuff. Sherry is asking, like, can you define the pipeline here again? Like conceptually, what does that mean? And I know you'll give some examples, so maybe we can show it.
Right, I'll do this in the demo, which in fact, the demo itself, I'm going to show you several things. I'm going to show you how do you create a pipeline using the visual pipeline editor in Elyra, how do you run the pipeline in JupyterLab, and how do you run it in Kubeflow pipelines. The demo that I'm showing you here while I'm switching screens is based on a bunch of tutorials that that we have published. So let me just make sure I'm in the right location here. Okay, so I'm just going to start my JupyterLab in my local environment here, and it should come up in my browser. Okay, and this should look familiar to you. Let me actually switch to, I don't know, let me actually stay here. So what you see on the right-hand side is the launcher that you're probably familiar with, giving you access to common features like how do I create a notebook, how do I access the console, how do I do other things. But one thing you notice in this installation of JupyterLab that I'm running here on my machine, which is a development build of JupyterLab and Elyra, I have now access to additional tasks, right? So I can see I can now invoke the pipeline editor, I can create a Python file, or I can access the documentation. So let me start off by simply importing a project that I have stored in GitHub. So in order to do that, I just open up the Git entry here, clone a repository. I need to specify a URL. So I'm going to do that by simply copy and pasting something in here. So in the background, JupyterLab is now cloning that repository into my workspace. And you can see here, I have already a bunch of files in there. So let me drill down into one of the directories here and open one of the notebooks. So now this view here is very familiar to you, right? It's the classic notebook interface where you can see the cells, the documentation that you have, you can step through the cells. But the reason why I'm opening this up is to show you some of the features, some of the productivity enhancements that we have put in as part of the Elyra extension. So let's say, for example, I'm making a change to this notebook, right? So let's say, for whatever reason, I'm adding a cell here, and then I'm going to also run it and run a couple more cells here so that I can produce some output. So if I now switch to the GitHub view here, you can see that JupyterLab now alerts me to the fact that I have a notebook here that has been modified, right? And if I'm curious, okay, what are the changes that I have applied? I simply right-click on that notebook. Actually, it should have. Oh, I forgot. Sorry, I need to save my changes. And now, in the background, JupyterLab is comparing the changes that I have made with the original notebook. And if I now look at the difference between those two versions, we can now see that, indeed, I did add a cell. I have some more output. And if I scroll further down here, I can see that in this one cell that I ran, I can see now that output, right? So I don't have to leave my JupyterLab environment anymore to figure out, okay, what are the changes that I have made? One thing that I really like about this GitHub feature, and I only accidentally stumbled across it a little while ago, you do have the ability to, of course, stage those changes and then commit them back into the repository. So I'm not going to show you that. But you also have the ability to discard changes, which can be extremely useful. So let's say, for example, you're running a notebook, all the output cells are now populated, and you just want to get back to its original state, right? If you just discard those changes here, it will do that for you, right? Without you ever having to leave your JupyterLab environment. Now, let's say you are working with a notebook that is a lot longer than this one. Let's say it's a monolithic notebook that spans 20, 30, whatever number of pages, right? One typical problem that you probably have is it's extremely hard to find things in your notebook, right? And this is where the table of content feature is probably going to help you a lot, because what happens is if you switch to the table of content view here, or if you open that panel, we automatically generate that table of content for you, right? And if you click on one of the section headings here, we actually jump to that appropriate place in your notebook, right? And you can see if you have a longer notebook, this makes it extremely easy to just get to the place where you want to be. Now, this capability of generating this table of content for notebooks is not unique. I mean, it's also available for Markdown files, and it's also available for Python scripts, right? So the same kind of concept applies there. So another typical problem, and we've discussed this when we went through the pain points, is let's say you have some common code that you frequently use, right? So let's say, for example, you have a certain type of visualization that you really like. If you're working on a notebook and you need to put this code in, I mean, what do you do today? Most likely, you're trying to find another notebook where you've already implemented that code, and then you're going to copy and paste it. Now, the problem there, of course, is if you have dozens or hundreds of notebooks, well, where's that notebook, right? Do you have it readily accessible or not? If you define code snippets, you won't have to deal with that anymore. Very simple to create a code snippet. You just give it a name. I'm just going to give it a trivial name here. You choose the language in which the code snippet is defined. So in this case, I'm just going to define a markdown code snippet. I save it. It now shows up in my palette here. And now if I want to use this code snippet, and actually I'm going to use one of the predefined code snippets that I have already in my workspace here, I can simply insert this into my cell and I'm good to go, right? So this over time you will see it can be an extreme time saver, right? Because now you do have this reusability aspect of code that you didn't really have out of the box with previous.
Patrick, it really reminds me of GitHub gists, and I'm wondering if there is any connection there, or if these can be saved somewhere like that.
Yeah, so I at this point, those code snippets are stored as part of internal metadata in the local file system. So we currently don't have the ability to export, for example, or share code snippets in other environments, but it's definitely a good idea. One thing we're looking at is how can we make it easier for users to share those code snippets, right? So whether it's through a gist or whether we have something like an import and export feature where you can choose which code snippets you want to export and then another user can import those. It's still a work in progress. Okay, so then let me move on to the pipelines and the main reason I think why most of you are here. So let me go back to my set of notebooks that I have predefined, and let's start building a pipeline. So I've opened the pipeline editor, and now I'm just going to drag and drop a bunch of scripts and notebooks onto my canvas here. So in this case, I'm going to build a fairly simple pipeline. Where you place those we call them nodes on the canvas doesn't really matter, because dependencies between those nodes you define by connecting them. So if you connect the output port of a node with the input port of another node, that implicitly defines the execution order, right? So if we were to run this pipeline now, it would first execute this Python script and then followed by this notebook here. But what I wanted to show you here is you can also model something like this, right? Where if this second notebook here completes successfully, then both of those other notebooks would be run in parallel because the only dependency is on this first notebook, but not on each other. So this is how I simply built or assemble a pipeline. Good practice, of course, is to document what a particular node is doing. So I'm just going to put in here load data set, so that if, for example, I save my pipeline and then share it with Upka, that he knows, okay, what was my intention, right? What am I trying to do here with my pipeline? So he doesn't necessarily have to look into each one of the scripts to figure out what is the purpose of a particular node that I have added here to my pipeline. Now, before I can run a pipeline like this, I have to define its runtime properties. And I have to do this for every single node. So for Python script, I have to specify what is the runtime environment or Docker image in which I'm going to run this if I want to run this pipeline in a remote environment. But I also can define input file dependencies. So let's imagine you have a notebook that is using some Python code, right? That you have stored not in a package, but maybe it's just stored in a Python script. You can define this as a dependency here, and then Elyra will take care of packaging everything that you have identified as a dependency with this pipeline, so that when you run this in the target environment, everything is available to you. If your script or notebooks have a dependency on environment variables, you can define those. And in my example here, I do need to define one of those variables, and I have a cheat sheet open so that I don't have to type everything in. And this didn't quite work as expected. Let me do it again. So I'm just copying the value that I need to put in here, pasting it. And last thing I have to specify is what are the output files that a particular node is producing. You'll see when we run this in a Kubeflows environment, why we have to do this. In my case here, I just have to specify a single data file that this node is downloading from cloud storage for me. So specify this as my output. I'm saving my change here. And you'll notice that nodes in my pipeline that haven't been configured properly are now tagged, right? So you see that little dot here. That's a warning indication. If you were to try to run this flow now, you would fail, right? Because you haven't defined all of the runtime properties. So I'm going to do this. Just take a second here. So this one is also going to use a pandas image. It's going to produce a cleansed data file based on the input that it has received. It doesn't have any dependencies on any input files, on any other input files, and it doesn't have any dependencies on environment variables. So I don't have to configure this part. And the last two notebooks here in my flow, I just have to configure that they use this pandas image. The general rule that you have to follow is you can use any of the public images that are listed by default, but you can also use your own images. But of course, those images have to make all the prerequisites. So for example, the prerequisite packages that you are using in your notebook, they have to make those available so that when you actually run this pipeline, that all its dependencies are met. So let me save this pipeline here. And now we are actually ready to run it in our local environment. Now, out of the box, when you deploy JupyterLab with the Elyra extension, you can run all of your pipelines in JupyterLab itself, right? So you just give it a name. By default, it uses the pipeline name. You can see it chooses the run in place locally runtime configuration, which is there out of the box. And when you click the OK button, let me just switch to my console here. You can see now that we run each one of the notebooks, and you can see how this is slowly progressing in a subshell, right, within JupyterLab. Now, as you can imagine, this works nicely for like small workloads that you have. But if you have large amounts of data that you need to process, if you have notebooks that are performing compute-intensive tasks, this might take a very long time, right? And that's why we typically don't advise you doing this in the local environment. However, if you're just going through initial development of a pipeline, it's perfectly fine to do what I was just doing here. Now, when the job has completed execution, I'm going to get a notification message. And you can see now the changes reflected in my file browser, right? We can see now there is a new data directory, which contains some of the data files that have been downloaded. If I go back up and open one of the notebooks, I can now see that the output cells have been populated, right? And now I can look at the results. So for example, if I open up the data analysis notebook, we should see some visualizations, right? And so I didn't have to go through each one of the notebooks and run them. I could just kick off this pipeline and everything was done for me. So this is how you would run a notebook locally in your environment. Now let me show you how you would do this in an environment where you have access to Kubeflow pipelines deployment. So I'm just going to invoke the same run button here, but this time I'm going to choose a runtime configuration that I have pre-configured in preparation for the demo here. So I'm not going to show you how I did this. This runtime configuration basically just includes the connectivity information where my Kubeflow pipelines deployment is located. And it also includes information about a cloud object storage instance that we are using to store the data that this pipeline is producing. Now, what happens when I submit?
I'm so sorry
sure.
to interrupt. You were just pointing that, so I thought this was a question I can ask now. So Tanya is asking, where is the output data stored in between the notebook steps? And I think you just showed that to us in the file explorer.
Okay. Right. If you run a pipeline locally, everything is stored in your local file system, because each one of the notebooks and each one of the Python scripts that you run is executed in the same environment. So in essence, you are in a shared everything environment. So you have access to it in your file browser. However, when you run this in a Kubeflow pipelines environment, in that case, each one of those nodes in your workflow is executed in isolation. So if my workflow here comprises of 4 nodes, each one of those nodes is executed as a separate container, and each one of the containers is isolated from the others, right? So when I run my load data Python script, it doesn't have access to any of the data or any of the information that's accessible to this notebook here, right? And in order to solve this problem, we use this cloud object storage instance that we can use as the medium to exchange information between those 2 nodes. So when I kick off a job like I have done, this dialog comes up, which gives me 2 links. The first link that I just opened opens up the Kubeflow Pipelines console, in which I can see the execution. So this is what you would typically use for monitoring. You can see that in this case, the first node, so the first node in my flow, has already completed. The second one is currently in progress. If you're interested in what's happening, you can just open up the log file and follow along. One thing you notice is you don't see the complete graph, right? You only see the nodes in the execution graph that have already executed and that are currently executing. So if we wait just a couple more seconds here, those other 2 nodes that were dependent on the data cleaning process should show up, and you can see this here. And again, if I switch to that node, I can access the log file and then monitor the progress of those operations. Now, this pipeline that I'm running here is, of course, a very simple one, right? It just takes about a minute and a half to complete. But imagine a scenario where you're working with a lot of data, right? Where you have a data analysis or some model training where you want to take advantage of GPU or TPU resources that you might have available in a Kubernetes cluster. This is really where you get the performance boost, right? That you would never see if you were to run this pipeline in your local environment. Now, when this pipeline execution completes, I can access whatever artifacts have been generated when that pipeline was executed. And in the current release of Elyra, you access those artifacts by using a browser that gives you access to that cloud storage instance. So fortunately for us, out of the box, when you deploy Kubeflow pipeline, an instance of MinIO is already pre-deployed for you. So you get everything that you need. And if we now look at the bucket, which I've pre-configured for this particular runtime environment, we can see that I have a pipeline here, and I actually see this is the untitled 1 pipeline that I was just running. We can see if I drill down the data files that have been produced when I ran this, and you notice here it's just 2 files, right? It's only those files that I have declared as output files. So anything else any other files that might have been produced while one of the nodes was running wouldn't be available to you unless you have declared them. If I go back to the root directory, if I download one of those HTML files here, if I open it up, we can see an HTML version of the completed notebook, with all the output pre-populated, right? So if any charts were produced, you can access them here. So if you just want to preview what the results were, you would just access the HTML files. If you wanted to access the IPython notebooks with the output files, you can easily do that by selecting all of the files. For example, if you use min.io and downloading everything as an archive from the cloud storage instance. So before I close my demo here, there's one thing I wanted to call out. As you can imagine, having to manually access those output artifacts through an external browser window isn't really very user-friendly, right? So what we are looking at and what we're working on is integrating this more seamlessly into the Jupyter Lab environment, so that, for example, you might be able to access those artifacts through the file browser, or we might introduce something like an cloud storage browser that gives you access to the bucket so that you can very easily download those artifacts into your browser and into your file browser and access them there. So with that, I think I've covered everything I wanted to show. So Upkar, if there are any questions that have come up as part of the demo here?
I've tried my best to answer a few of them, but there's a couple more. So one of them is, let me read the latest one. So the question is, in your Jupyter Lab notebook, how do you access the min.io data source? So that you showed it in the Kubeflow version of it. And I guess they're asking how to configure that.
Okay, so how do you configure the notebook? Very good question. If I understand it correctly, so let me be a little bit more clear. Let me open up this notebook here. When we look at this notebook, what you see, and then hopefully you can read this, and this is not too
it's coming through.
for you. Okay, so maybe this is a little better here. So you can see this notebook doesn't really know anything about the fact that this data file came from cloud storage, right? The notebook itself assumes that the data file is available locally, and Elyra is taking under the covers care of making this file available to the notebook. Because what happens is, if I go back to the pipeline here, let's say we're running this first node here. The node completes its execution. Elyra will then automatically download or upload all of the files that you have defined as an output file to the cloud object storage instance. And before the second notebook here is executed, what Elyra will do is it will download the files that are on that cloud storage instance back into the local file system, right? So that when this container runs, where this notebook is being executed, the file that I have declared as an output is now available to the notebook without you having to do anything. So in essence, you don't have to customize your notebooks to actually do this, right? This is done for you and completely transparently.
Perfect.
Does that answer the question?
I think so.
Yeah.
Thank you.
Okay.
Thank you, Patrick. So very similar to that, and I know we are a little bit running over, but I think there are lots of questions. So let's, if it's okay with you, let's stay. Let's stay and finish this.
Sure.
So the next question that's very related to this is Sherry asked if everything that goes into the Cloud Object Store as output, everything has to be configured. Unless you declare them, you won't see them. Is that correct?
Yes, that is correct. Fortunately, you won't have to, like in this case, I specified a single file, right? But what you can do is you can also specify wildcards. So for example, if I put this in data /**, then all of the files in this data directory would be exported. So you don't have to specify every single one of them. But yes, the answer is you're absolutely correct. You need to define it, otherwise it will not be available to you.
Okay, perfect. And then we have another one here. Sorry, the questions are all in the chat instead of the Q&A portion, so I'm filtering through
No
it
worries
here.
at all.
Okay, Luciano kind of answered one of them. The question was, how do you tell which COS to use, which cloud object storage
Okay, yes.
to use? And that's the runtime metadata that you tell it which, because I think the original question was, how does it know to use min.io?
Yes, right.
Okay.
Let me actually show this. I didn't want to show it as part of the demo, but it's fairly easy. So if you open up this runtime wizard that Elyra introduces, if you create a new runtime environment, you give it a name. This can be anything arbitrary, and then you define like what is the endpoint where this kubeflow pipelines instance can be accessed. You specify username and a password if that instance is protected, and this is where you would specify, okay, what is the endpoint for the cloud object storage instance that that you are using? What is the username? What is the password? And what is the bucket in which those artifacts will be stored? And I had done this in preparation for the demo. Let me just open this one up. You see here on the left-hand side, when you define this, you get essentially two links. If you open up the first link, it drops you right into the kubeflow pipelines console. If you open up that second link, then it opens up that browser window for you.
Cloud object storage. Okay, perfect.
So you just have to define it once, and then it's available for all of the pipelines that you have associated with this runtime environment. And what we tend to do is we tend to use several environments. So we have a kubeflow environment for development. We have one for test, so that you can very clearly separate the different projects that people are working on.
Perfect. Another question from Andre: is it possible to connect a JavaScript module to the pipeline?
JavaScript, at this point, the answer is no. So the only two types of nodes that we are supporting right now is Python scripts and Python notebooks. I don't think we actually are going to support the JavaScript nodes in the future. But one thing that I should probably call out is, even though everything we showed today, right, was evolving around kubeflow pipelines, our intention is to make pipelines available in other environments as well. So, for example, if you are a customer who has or who uses Apache Airflow today to run workflows, you will be able to run this pipeline on in such an environment as well, right? So we try to be here agnostic, and then so if the target environment supports execution, for example, of JavaScript code, then there would be something that we can do in the future to run such code or such a node in that target environment. But for the time being, in this first release here, we're just focusing on two environments, running locally and running in kubeflow pipelines.
Perfect. There were a couple of comments on how can I try this? Can I try this? Where do I get this code? And I know you're getting into that, so that's a good segue into the next portion here.
Yep, exactly, right. And we have only two more slides here, so let me switch over. So how can you try this out, right? And we have several options for you. Not sure if everybody on this call is familiar with Binder. It's basically an open source project called Repo to Docker that gives you the ability to create a Docker image from a GitHub repository. We have done this, and we have published a Binder image for Elyra. So when we share the slides here, you have the links handy. So, but if you click on this link here, what happens is it will open up a sandbox environment in the cloud that is being hosted for you. And then you can try these things out without having to install anything. The disadvantage, of course, is since this is hosted in the public cloud, the resources that you have available are extremely limited. And once you shut down that image, you lose everything that, that you have done. A better approach is therefore, if you want to run Elyra in a Docker container, the community publishes a set of those containers. If you look at the tags, the latest public release of Elyra is always tagged as latest. If you're looking for a specific version, you just specify XYZ as the version. So the most current version that we have as of today is version 1.2.1. Or if you feel really adventurous, if you use the dev tag, then you will have access to Docker container that contains the most recent development build. But of course, that build might not be very stable. So I personally wouldn't really recommend using those containers for anything else but basic exploration. Last option that you have is, of course, you can install Elyra and JupyterLab locally in your environment. So if you have Node.js and Python 3 installed on your machine, you can pip install everything. If you're using Conda as your package manager, you can use the Conda recipe. Or if you'd like, you can also install everything from the source code. And the link that I have here has all of the details that you need for each one of those options that we are providing you with. Last thing that we wanted to share here is if what we have presented today to you seems interesting, we are more than happy to welcome you to the Elyra community. So if you open up the link to the GitHub repository that we are showing here on top, you have access to all of the information that we have shown you today. We have a community meeting every Thursday where we talk about the latest developments, where we have users ask questions, give us feedback, for example. We're also on Gitter. So if you want to get a hold of us in between those community meetings, you can easily do that. We've also published a bunch of pipelines that you can use to try this out. So what I was showing you was the tutorial pipeline that walks you through those tasks step by step. But we also have some more complex pipelines. So probably our most appealing example as of today is the COVID-19 pipeline. If you go to this GitHub repository, you get everything that you need. You get the notebooks, you get the pipeline. You simply clone the repository into your workspace, into your JupyterLab environment, and you're good to go. And you just follow the instructions there. There are two more pipelines that we're working on: an airline delay analysis pipeline that is going to go through some more in-depth analysis of two data sets that we are processing. And then it's going to do some prediction, trying to forecast, okay, how good or bad are airlines going to perform in the future based on some weather patterns. And then last but not least, we're also working on a pipeline that illustrates how you can analyze how fair your models are, right? So if you want to identify, okay, is there bias in the model that I have created? A pipeline like this can help you find the answer to that question. And last but not least, if you want to reach out to us, we are on the web at codea.org. We're on Twitter at codea.org. Or if you want to reach out to either Upka or myself personally, you're more than welcome to either ping us on Twitter, send us an email, or reach out through any other means. So that's all I had, Upka. I don't know if there's anything else that you wanted to bring up, or if there are any more questions that we can answer.
No, this is perfect. This is perfect. Patrick, I might have missed it. Did you talk about bias at all at the end there?
I just so I brought it up in the context of this this pipeline. But if you do want to say a couple of words about it, I didn't, because it's more of an advanced topic, but definitely a very important one.
Got it. So Sherry was asking, how does pipeline help uncover bias? So I think, Sherry, the idea here is the coming soon, the AI fairness analysis that'll have some pipelines the pipelines themselves don't help uncover bias. Pipelines are a way for you to run your code, as Patrick showed today. No, that was great. Thank you, Patrick. Luciano had a comment here, which I want to read out because I think this is the amazing awesomeness of open source. He says, Elyra is open source, so you could create an issue describing your use case to use JavaScript and even come and contribute. So as Patrick, you were saying, welcoming people to the GitHub repo and the community at large. I think that's a really good point. So I think Andre was asking about JavaScript. So Andre, again, this is an invitation for you to come and contribute.
Mm-hmm. Yeah, definitely. And then we are, I mean, so when we're looking for contribution, right? So we are looking for general feedback that you have, right? We are looking for if something doesn't work for you, right? Open an issue, file a bug. We're happy to fix it. If you have an enhancement request, like what you were mentioning, okay, is that the ability to run JavaScript? Open an issue. We'll, as a community, take a look at it. If there's a viable approach to doing it, we might be able to deliver. If you'd like to contribute code that can actually support what you're looking for, you're more than welcome to open a pull request, right? And then that edition would be part of the official code base. So there are different ways that you can contribute to Elyra or Jupyter Lab in general, right? Because I mean, at the end of the day, it's really not about Elyra. It's about making Jupyter Lab a better development environment for every one of us, right? Who's using it on a day-to-day basis. So if, for example, and this is something I didn't really get into, traditionally, when you used like the Jupyter Notebook interface, all you could do is really interact with notebooks, right? But with Jupyter Lab being an integrated development environment, you have now a lot more options. So let's say, for example, if somebody were to implement a CSV file editor, you could now natively open CSV file in Jupyter Lab. You could browse the files, and you might be able to automatically generate some charts, right, based on the data that's stored in there, right? So that there are many opportunities where contributors can now add functionality to Jupyter Lab that traditionally wasn't available to you in a notebook, or was only available to you if you actually coded this in the notebook itself, right? So Jupyter Lab becomes more of an ecosystem of extensions that just make your life easier in every single way possible in your day-to-day activities.
I thought there was already a CSV editor, because when I remember when I moved from Jupyter Notebooks to Jupyter Lab, like that was one of the things that I was so happy that there's a way to see my CSV files, like big CSV files, right in Jupyter Lab. They might have, I don't know if they took it out or if it's still there, but that was one of the you don't have a CSV. Oh, yeah, yeah, that was one. Yeah, here. So for me, it was I'm like, I'm all in. This is exactly what I want.
All right. So maybe this was a bad example, but just think about the potential here, right? If you want to do more than this editor can do at this point, right? Just extend this extension, and everybody will benefit from it.
I'll get you started on that if anybody's interested. When I was looking at this, I didn't find a way to sort by column. So if somebody wants to implement sort by column, that'll be good. All right, cool. There's a comment from Sherry on, okay, so I think PyData meetups is answering. Perfect, they've answered that question. So I think we're all done here, Patrick. Thank you so much. And thank you, PyData, for having us over and talk about Elyra. You can see Patrick, myself, Luciano, we are very passionate about this project. I think it's an amazing project, so there's no reason not to be. And if you have any questions, Patrick, can you put the, oh, never mind, that's okay. I was gonna ask you to put the last slide up, but let's put in our Twitter handles in the, perfect.
I've put it back up, and then we're going to share the presentation with everyone so that you have the links.
Awesome. Thank you, everyone. We'll see you next time.
Right. Thanks for having us.